Okay, today's lesson is the last one we're going to cover in this chapter, and it is the fundamental theorem of algebra. So, what you need to know, if you don't know already, is that the degree that we've talked so much about, the degree of any polynomial equation tells us how many roots the equation has. Okay, so this is it in math speak. If p of x is a polynomial of degree n, which is greater than or equal to 1, then p of x equal to 0 has exactly n roots, including multiple roots and complex roots. So, depending on whether you have to only find the rational roots or find all the roots, okay, remember when we talk about multiple or multiplicity of a root, you're using the exponent of the factor, okay? And if you forget what that is, then write down, come ask me about that. Okay, so we're going to take the process of what we've been working on the whole chapter, okay, and put it down in defining all of these roots for a fourth degree, fifth degree polynomial. So here's our first example. What are all the roots of x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4 equal to 0? So how many roots is it going to have? Okay, how many roots? We're going to have 5 roots because it is a fifth degree polynomial. Okay, so first and foremost, when you are working these problems, you always want to make sure that you have your polynomial set equal to 0, or your equation, your equation that you're dealing with. Okay, so you set it equal to 0. The second step that we have is what we just learned in the last section, or 2 sections ago. I think it was the last section. Okay, and that is the possible rational roots. We're going to list those. Okay, and remember that's when we take the factors of this and put it over the factors of that. Ooh, so that's a 1, so we really only have to worry about the factors of 4, which are plus or minus 1, 2, and 4. Okay, so those are our possible roots. And then the third thing we did was we made a t-chart this time. You can, if you have access to a graph, you can do a graph to limit this, okay? But you got to do it algebraically. So when you're doing that t-chart, okay, we're doing x and y because we're looking for the sign, S-I-G-N, sign changes. And when I did it in the last lesson, I only went from -1 to 0. But I'm going to go ahead and write all of these because this will, I'm going to start at 0, 1, and -1. But if I need to go further, then I'm going to use 2 and -2. Again, it's just helping us narrow it down. So I hope you remember that 0 is always our constant, okay? So if I plug in 0, I'm going to get 4. And then we talked about if I plug in 1, that means I just need to add up these coefficients, okay? So 1 minus 1 is 0. -3 plus 3 is 0. And -4 plus 4 is 0. So boom, I found a root right there, okay? Whenever we get 0 in that table. So that means I'm going to go over here and start with 1. All right, and we write our coefficients because, oh, and that's what I should say, when you find it, so our fourth step is we're going to use synthetic division to find those roots. And basically that says synthetic thesis. I don't know what I was thinking. Oh yeah, I think I was gonna write out synthetic, and then I decided not to, but let's go ahead and write it out. Synthetic division, okay, with the roots that you find. And you're always trying to get it down to a quadratic, but it's easier to say second degree, so I'm going to write second. Okay, so I have a 1, and now I'm going to write the coefficients, and that's a 1 and a -1, -3, 3, -4, and 4. 5, 4, 3, 2, 1, just make sure I had all of them. Okay, and so then, and remember what I like to do, if I know it's a root, then I know 0 has to go here, and of course that means that's going to be -4. So that just lets me know when I go through all this, if I don't get to that, I've done something wrong, and I'm going to check my math at that point. Okay, so we always carry down the 1, and then we multiply. 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 is 0. Um, Negative 3 plus 0 is negative 3. 1 times negative 3 is, what's 1 times negative 3? Negative 3. 3 plus negative 3 is 0. 1 times 0 is 0. Negative 4 plus 0 is negative 4. And 1 times negative 4 is negative 4. So we're good to go. So one of the things that I want to point out with that, okay, remember that this is a fifth degree, okay? And so that means this next one right here is a fourth degree, okay? All right, so I have to keep going. So I really need to go back to my t-chart, okay? And let's go, you can pick a number. You can go to -1, you can go to 2. I'm just going to go to 2 just to see what happens. So if I put in 2 into all of this, and you can pause, put it in your calculator, but if you put in 2, you're going to find out also that it's equal to 0. So that means it's a root. Now this is the important thing that you got to remember. When you divide and your polynomial goes down by 1 degree, this right here is what is referred to as a reduced polynomial. Okay? Um, you all know that that was x to the fifth. This is now x to the fourth because it goes down by 1 degree each time. So when you put the second one in there, you need to be sure to use the reduced one, or else you're going to be spinning your wheels. Okay, because we're going to keep putting roots in here until we get down to a quadratic. Okay, so I'm going to go put in 2, and when I do that, carry down my 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 plus negative 3 is 1. 2 times 1 is 2. Oh, remember this, I know it's going to be 0, and that has to be 4. 0 plus 2 is 2, and 2 times 2 is 4, so we're good. And so that means this one right here is a third degree. So that actually doesn't look too bad. When you look at it at that point, you can either go back to your table, but what if we know this is a third degree, so that's x to the third plus 2x squared plus x plus 2. And the reason I said this wasn't so bad is because I noticed that these are the same numbers, but what's different is the x's, so we could factor this by grouping. Now, if you didn't notice that, y'all, you just go back and fill in again and see if you can find, well, obviously it's going to be 2 or 4. You would go to 2 and -2. But I'm going to factor out and just review our factoring that we've done. So I factor out x squared because that's in common, and that leaves me with x plus 2. Always bring down that sign. What do those have in common? A 1. That leaves me with x plus 2. And so my common factor is, I don't know what that was, x plus 2 times x squared plus 1. So as we keep going, oop, I run around the room here. Did you like that? Just move that up a little bit. Okay. So I set each factor equal to 0. That gives me x plus 2 equals 0, and x squared plus 1 equals 0. And that, of course, means that x equals -2. And this says x squared equals -1. So x equals plus or minus the square root of -1, which is what? So if you remember, that's I. Okay, so to answer our question, okay, what are all of the roots? All 5 of them. Well, how many I have? 1, 2, because plus or minus is 2, 3, 4, 5. So when you answer the question or put the answer blank, you got to say x is equal to 1, 2, -2, plus or minus I. And now I have accounted for 5 roots of this polynomial. Okay? Now, ask yourself, if you don't know, is there more than one way to do this? Absolutely. Okay? If you wanted to go ahead and plug into a table and try -2, -1 and -2, obviously if you put in -2, you would have gotten 0. Then you would reduce it again and you'd get down to a quadratic. Okay? So it's really important for y'all to work these problems yourself. Please don't go copy anybody else's work, because if you don't work through it and try to figure it out on your own, you probably won't be successful. Okay, so what are the roots of these equations? Remember, the first thing we do is we're going to set it equal to 0. So I'm going to have x to the fourth plus 2x cubed minus 13x squared plus 10x equals 0. Because I think y'all know by now that we're taking this to the other side. Okay, the other thing to check, how many roots am I going to have from my fundamental theorem of algebra? I'm going to have 4 roots. So I got to go find all 4 of those. Okay, so now I'm going to go find the possible, I really just wanted to abbreviate that, the possible rational roots. This is interesting. Okay, there's a common factor already, and I should have figured that out. Okay, because I looked and there's no constant term. So if there's no constant term, that means there's a common x in everything. So I'm going to take that x out, and that's going to give me x to the third plus 2x squared minus 13x plus 10 is equal to 0. So really what I'm worried about is this polynomial because I already know that root. That, of course, is 0. So I'm looking for these 3, and that means that my possible rational roots are going to be the factors of 10 over 1, which is going to be 1, 2, 5, and 10. And then we did our little t-chart or table, t-chart. Okay, now, what did we do? We choose -2, -2, -1, 0, 1, and 2. And we already did 0 was 0 because we knew that in the very beginning. So you don't want to do, I mean, either way, however. Excuse me. So now put in 1, and remember that's 1 plus 2 is 3, and 3 minus 13 is -10, plus 10 is 0. So I have 1 as a root, okay? Um, it's a cubic, so I don't need to go past that. So let's go, the next step, of course, after our t-chart, excuse me, is synthetic. There I go again, synthetic division. So I'm going to take that root of 1, and I'm using this polynomial. I don't need to worry about that. So that's a 1, 2, -13, and 10. And that, it's a root, so I know I'm going to get 0 because that's what our remainder or factor theorem says. We have, bring down the 1. 1 times 1 is 1. 2 plus 1 is 3, which means this is going to be -10. Sorry, jumped on that. 2 plus 1 is 3. 1 times 3 is 3. -13 plus 3 is -10, and 1 times -10 is -10, so we're good. And then that gives us, okay, this, remember, was a third degree, because that's what that tells us right here. So this one is a second degree. So that means I have x squared plus 3x minus 10 that I need to set equal to 0. And I know there are factors of 10 that subtract to give me 3. And that, of course, is 5 and 2. And so I need a positive 3, so I'm going to have a positive 5 and a minus 2. So I'm setting each one equal to 0. X plus 5 equals 0. X minus 2 equals 0. And that tells me that x equals -5 or 2. Where are my other roots? There's one right here. 1. And where's the last one? Because I got to get 4. Y'all remember the last one? The last one was right here that we didn't need to check out, or right there, however you want to think about it. So the last one was 0. So now I've accounted for all 4 roots of my equation. Okay, one more example that I want to show you is this one. I put the graph in here just so that you would have it. What are all the zeros of the function? And there's the function. Because if you have access to a graphing calculator, you can put it in there, and I can kind of show you how it can be used to help you, which would be something that might be helpful on ACT if you have this type of question. Okay, so to start off with, it's already set equal to 0. So that part, because we would replace that as 0, or when you graph it, that means What are the zeros? Remember, they're right here, okay? And it looks like this number, okay, is 2, and it looks like that number is negative 1. And how would you find that out for sure? Of course, you could go calculate p of 2, and we can go do p of 2, but we're just going to go divide it. So let's go do p of 2. Let's go synthetic division with 2. Gives me 2, negative 3, negative 1, and negative 6. And I'm hoping I'm going to get 0, but I'm going to leave it because I'm not sure. It could be just a little bit off. I do know, and I probably should have started with that, y'all. What are possible rational roots? Okay, is 2 even one of those possible numbers? So if we looked at that, remember we have plus or minus the factors of 6, 1, 2, 3, and 6 over the factors of 1 and 2. So we know that 1, 2, 3, and 6, so yes, 2 is a possibility. And it doesn't look like we have any fractions, so I'm not going to worry about it past that, because I think y'all know what to do. All right, I bring down my 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 times 1 is 2. Negative 1 plus 2 is 1. And 2 times 1 is, I did something wrong. Y'all aren't here to help me. Hope y'all figured out what I did wrong, or maybe you've been yelling at me for the last 5 minutes and I didn't know it. Okay? So, x to the 4th, x to the 3rd, there's no x to the squared, or x squared. I needed to put a 0 in. Okay? So now let's see if that doesn't help my problem. So I was good to there. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 1 plus 4 is 3. 2 times 3 is 6. And negative 6. Bingo. So we got it. This is our 4th degree. And this, of course, is our 3rd degree. So now what am I going to try with this one? I'm going to try that other side and see if it's not a root. Negative 1. So we're going to try it. Bring down your 2. Negative 1 times 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 1 is positive 1. 2 plus 1 is 3. Negative 1 times 3 is negative 3. And 3 plus negative 3 is 0. So we got it. And this now is our 2nd degree. And so from here, I have 2x squared minus x plus 3. Are there any factors of 6 that add to give me 1? Well, there's no way I can add the factors of 6 to get to 1. So this thing cannot be factored, okay? So keep that does not factor. And since it doesn't factor, and I have an a not equal to 1, I'm going to use the quadratic formula. Sometimes we have to do that. Okay, we haven't done it much thus far. Okay, so when I use that quadratic formula, a is equal to 2, b is equal to negative 1, and c is equal to 3. So from here, what do I have? My quadratic formula says x equals, it's a bunch of stuff all over 2a, negative b plus or minus the square root of b squared minus 4 times a times c. Alright, so that's what we have. And if we want to simplify that, that's going to be x equals 1 plus or minus, in my way, plus or minus the square root of negative 23 all over 4. And really the only thing you need to do with that is you can't leave that negative there. So I'm going to say, let's go with our final answer. I'm going to write x equals 1 plus or minus I square roots of 20. That's what I was going to say, 23 over 4. Nothing cancels. Comma, what were my other two roots? 2 and negative 1. Okay, so this is the thing with the fundamental theorem of algebra. We didn't have any multiple zeros. Doesn't mean you won't when you do your when you practice. But that's 2 roots, 1, 2, 3, 4. And what degree was our equation? It was the 4th degree, so we have 4 zeros that we can account for. Okay? So there's a summary of our fundamental theorem that you can read and get to. And if you have any questions about anything, please come see me.